Hey guys, this last week I've been mainly focusing on interacting with you guys, having lots of flights that I haven't been doing lately because I've been developing mostly, and I learned a lot from you, and you guys asked a lot of questions, which is good. Keep them coming about some stuff, and that made me think. If you're just starting out and you jumped the bandwagon halfway through and we're already on the steam train going at 120 miles per hour, it can be quite daunting to get started into this hobby. So I want to go back to basics and each week take one component and just elaborate how they work, how you can code them up and how you can hook them up with Flight Sim. So we get a growing library of components that you can just watch the video that you need and you can start playing on your own. This week I'm going to be talking about push buttons. Next week we're going to be talking about rotary encoders. The rotary encoder and the push button articles have already been up on my website for my Patreon supporters, so thanks a lot for that. And if you're interested to get some benefits yourself, like early access to the beta build that is coming soon, exclusive 3D files or early access to the articles, be sure to check it out in the link down below. Well, first of all, let's get started with the push buttons. If we talk about flying, I've got to say I'm finally joined your ranks of being a bit more professional. Let's see. Here we go. It's a beauty. Hell yeah. It's the Airbus one from Trustmaster. I know that I can be sometimes a stubborn goat. I know I can be a stubborn goat sometimes, but you guys are right. A flight stick is 100 times better than a controller. So if you're out there and you're still using Xbox controller, PlayStation controller, and you have the spare money, so I'm gonna be honest, controller works fine if you don't. It's amazing. The reactivity of the airplane is miles ahead. So that's a recommendation. We're gonna go ahead straight over to the push buttons and see how they work. So wiring the buttons up is going to be quite easy. We're going to have two methods. We have an input with a pull-up resistor. We're going to have an input with a pull-down resistor. Now for the pull-up resistor, we need to connect the first pin to ground. And for the pull-down resistor, we need to connect the first pin to the 5 volts line. How they exactly work, I'm going to explain to you during the coding. But they both need to be connected to the board as well. We can connect them to any digital or analog pin. I always like to skip the 0 and the 1, so you could use the 2, 3, 4, 5, 6, 7 up until whatever number you have on your board. Now, if I press it, the pull-up resistor will run its current from the pin that we've connected it to the button, and if it's pressed, it can escape to ground. Now with the other one, the power will run through the button from the common power line, or the 5 volts line. Let's put it in properly. The other side will be connected to ground via a 10K resistor. I believe I have a 9.1K, but usually a 10K resistor is used. So we might be able to tell that it goes to ground, and then we connect the cable going to the board in between the button and the resistor, and then we just connect it next to the same pin that we've connected the other button to. Now in this one, the power runs from the 5 volts towards the board, and the other one, it runs from the board towards the button. So that's the big difference, and that will also be a difference when it comes to checking if the state is high or low, depending on which of these options you choose. The cleanest to wire will be the one with the pull-up resistor, because you don't need to add another extra resistor like we have on the right side. As you can see here on the left side, we only have the cable running from the pin and running to ground. This article, like I already mentioned, has been up all week to my Patreon supporters. But for you guys, it will be available in the comments description down below once the video is out. This one goes really in depth into how the push button works. As you might see, you can scroll quite down. There are some coding examples. There are some examples on how to use it with the connector. So it's all in here for you to read back if you get lost during the video or just want to read up at a later point. So how are we gonna code up the buttons? Well, we already saw that when we, let me zoom in. that when we wired up the buttons, we had two approaches. We had either one with a pull down resistor or one with a pull up resistor. If we use a pull up resistor, so the one where it goes from ground to our pin on the board, so pin 3 in this case, we call it an input with pull up. And if we have a pull down resistor, so at the end here with the 10K resistor going to ground, we call it a pull down resistor. There's an essential difference and an essential difference. And why is it? That if we have an input pull up, the power goes from our measuring point, so pin 3 goes to the button. But the power wants, and then it measures, can it go to the ground? Because if it can go to the ground, the signal will be low because it can flow through, it can empty out current from the cable, as to speak. So then we know that if the signal is low, because the origin point of the signal will be the board, so the signal will run from the board to the button. If we press it, the power can run to ground, and then we know that the button is pressed. So if we press it, the signal is going to be low because it will enable the power to go from the board or measuring point to ground. Now, because power always wants to run in a circle to ground, there is a little resistor inside of the board. That is the internal pull-up resistor that will give it a path to ground with some resistance, so it can slowly keep on rotating, send a signal, can slowly fade out. That's fine. So we can get, and this will take out the jitter on the line, make sure that you don't get any messy readings, etc. So we need a resistor at either place, but the board has them built in, so that's why we don't need to pull down resistor if we don't want to. But we need to define it as an internal pull-up as well. So we have the internal pull-up, and this one, it's the other way around. We have the 5 volts coming in from the main line. It goes to the button, and this is fine because we don't measure anything at this 5 volts, so we don't need to connect this to ground. The moment we press the button though, it's when the power can go towards the pin, and the moment we release it, the power will be cut off, but there can still be some remaining power, etc. So it will slowly take the road through the resistor to ground, and all is fine. So that's the different approaches, because in this one, the signal is low when we start at this measuring point, and the moment we press it, power runs towards it, and it's going to be high. So in this case, logic, we need to check if the power is low to check if it's pressed, and here we need to check if the power is high to see if it's checked. Are you still following along? Perhaps if you are a bit lost, the article where you can read up and about it, it's a bit more clearer. This is the most easy approach, and I would recommend to use this one most of the time. And it's easier to code up as well. It doesn't really make a difference, but I'm going to show you. I'm going to start by declaring the pins, and you could either use the hashtag define, let's say button yellow, so we both know what we're talking about. Yellow, and it's connected to pin 3. And we do hashtag define button green on pin 4. And when we define something, this does not create a variable. This creates a reference for our Arduino to know pin 4 or 3 have a name called button green, button yellow. This is just, let's call it an alias or a shadow name for this one without creating a variable. So if you wanted to create a variable, you could also do, it's going to be a constant because it will never change. So we say const byte button yellow 3 is 3. I would say const byte button green is 4. Now, if you use this one, we can't use both. So we got to choose which one we want to use. And I would say use this one just to have some clearer view. You could also, perhaps you're familiar with this one, int. You can do it with a byte. Byte is going to be the smallest data size compared to the int. So if possible, just go with the byte. Because you're probably not going to have a pin that's going to be higher than 255 because it's a max value of a byte. It's going to be from 0 to 255. If you had a pin on your board that had 500 pins, you would need an int. but that is usually not the case. So in the setup block, we are going to determine what kind of buttons we have. So if we have the button yellow, the button yellow is the one with the internal pull-up resistor. Now we want to activate that resistor because it's not on by default. So say input underscore pull-up. What this will do is tell the board this is an input on pin 3. And we need to activate the internal pull-up resistor for this particular button. Now we can do the same for the button green, but in this case we don't want the internal pull-up resistor to be activated. We want to use the pull-down resistor at the end of the circuit over here. So we're just going to say input. So now we have two buttons, and as we already might see, they have a different approach in coding them. We have the input pull-up with the pull-up resistor, and we have the input with our pull-down resistor. Once again, this one doesn't need a resistor physical, it's already on the board, and this one you need to add one in the end. So this is why this is easier. It makes it easier to wire up and makes it easier to just see. You have less cables running, less resistors needed. So I don't know. I think this is most of the times the easiest solution to choose from. Now, when we code up a button, there is some kind of logic behind it, right? Let's break it really down into a verbal, sentence. If, so we got our first keyword, if button yellow. So what do we want to check? Button yellow. So if button yellow. And what do we need to know of the button yellow? We know it has an input pull-up mode. So we know that if it's low, it's pressed, right? And we want to know if it's pressed. So if button yellow is low, do something. So notice the keywords that I'm hoping that I emphasize good enough. If button yellow is low. So that is how we know if button yellow is pressed. The other way around for button green will be if button green is high. Now, if you take it logic, we can almost verbatim fill in the gaps because an if statement will be the word if. So that is how I will know that if I want to check something. So if I want to check if the button is pressed, I'm going to use probably an if statement. If button yellow. So what? First we check if. Then we check what we want to check. So button yellow. Well, we can't really do button yellow because we need to, in order to get if it's high or low, we need to read the state. So Arduino has a function that is called digital read button yellow. And why it's going to be digital? Because it's going to be either high or low. There is not a value in between at 500 or 550. No, it's going to be either a 1 or a 0. And that is why it's called digital read. It returns a 1 or 0, high or low. So if digital read button yellow is equal, so double is sign, equal sign. That's in the Dutch we say is instead of equal sign. Low, closing brackets. So if what is in between these outer brackets is true, we do something. So if this statement would return false, so if digital read button yellow would be high, it wouldn't be low, so that would be false, this statement, we wouldn't execute this block. Now, in this case, let's assume it's true. What do we want to do? We get back to that later on when I show you how to use the connector. But I'll show you in a second first with serial. And we can do the same for if digital read button green, and this is where the difference will come in play, is high. See the difference? Input pull-up, we check if it's low. Input with a pull-down resistor, I'm going to check if it's high. So, here we go. Now to just have a quick check if it works, we're going to add the serial line. So we're going to serial.add begin 115200. I'm going to be using 115200 because we need it for the connector to work the most efficient. In most examples, you will see 9600, but because we're going to be using this later on, we're going to be changing this to 115200. I'm going to be using serial.print. Let's say Pullup. And we're just going to copy this. I'm going to say pull down. Now let's check if I have the proper board connected, 48, or perhaps I override my throttle. Okay, it's done uploading. We can check the serial monitor. If I press this one, pull up, there is no, because we didn't put in a delay, and the program can run pretty rapidly through the, how do you call it? The loop block. As long as we press the button, it will send the command. Now there is one thing we can do to make the debugging a bit more clean and readable. We're going to print a line, so it will print on a new line. And because we don't want to fire it 300 times, we're going to add a little delay. What a delay will do is freeze up your code for a set amount of milliseconds. So in this case, delay 200 milliseconds. So you could do this 5 times in a second, but for a fifth of a second, we freeze our code before we go to the next part, because it will just run from top to bottom. So the moment we press, it will freeze for 200 milliseconds, giving us the possibility to remove our finger. Now, if you have heavy fingers like I do, this might be even needs to go higher, or if you're a really fast button presser and you like it to be very snappy, you can lower it. Sometimes you don't need it at all. If you want something that you can hold, perhaps still need a little small delay, depends all on your needs. So play around with this to whatever you like. And if we upload this, we can already see the difference to what we had just a minute ago. Something should happen. Oh, the button is not in properly, but we'll see. See, we have the time to release it before a new. Can we do the pull down? And we can do the pull down. Perfect. So we'll see in the code the difference that we check high if we have a pull down resistor. We check low if we have a pull up resistor. Pull up resistor is not a real physical resistor you put on the board. It's a real one, and it's physical on the Arduino board itself that we just activate by declaring it as an input pull up. Are we still following along so far? If not, let me know in the comments below and I'll get back to you. Now, how could we use this to control something in game? Because we're going to load up a plane. So while it is loading up at the downloads page on my website, you can go to documentation. And here we'll get the documentation that belongs to the connector. Now let me grab the connector for you so you can see what I'm talking about. This can be downloaded from the downloads page as downloaded. This can be downloaded from the website as well. It's a piece of software that talks to our game and it interprets the serial communication that either goes towards your Arduino or comes from your Arduino. Currently they can be mixed, so we can't send and receive from the same device. We need a separate Arduino, but that is being worked on to be fixed. Well, what we're going to do right now is going to use an input. So I already have one defined, but I'm going to add another one. I'm going to stop it for a second. I'm going to select my new Arduino board, which is going to be the new Leonardo. So now it listens at COM port 45 and COM port 48 for inputs that it receives. So if we would start it, it would all be sufficient. It needs to receive certain commands to understand what it needs to do, right? Well, in the documentation, we have a whole set of functions. We have get AP vertical speed, get Coleman altimeter, get true vertical speed. But in our case, we don't want to get anything. We want to send something, right? So what are we going to do? We're going to look for the tables that it's set, or here we have handling inputs, so we know that here are the inputs for COM. There we have send COM whole, inc, send COM swap COM to. So you know what? For one of the two, I'm going to use the send swap COM1. But you could use any in this list that you want. Some make more sense to use at a button than others. Some are more logical on a rotary encoder, but all could be done theoretically. No, we're gonna use the flaps up and down. So we're gonna say send flaps inc. See this part without the int? I'm cleaning this up because this has been the biggest mess lately. So I've been spending all week sanding it down, and I think I'm almost at the finish line. But here we have a function that's called send flaps inc. So we go to our code. Now, like I mentioned, the connector listens to the serial line. So we already spotted that we're doing serial.println. So it sends something over serial at a rate of 115200. This is the speed at which it sends the data and reads the data. And because we wanted to be quite responsive, we put it a bit higher than usual, but it still does, like if you go really high, data loss could occur, or it could be too fast for the Arduino to handle. This is a fine middle ground for your Arduino to handle and to be snappy. So we're going to be at 1152. It's going to send the message Pullup. Now, our connector does not know what the words Pullup mean, so we're going to help it out a little bit. When we code up Arduinos, we could include a library. Now, a library, bits Android's flight connector in this case, .h, is a piece of code that is contained in a file, and the moment we use include, our IDE, that's how this environment is called, knows that it needs to include the code that is in that file with your Arduino. Why would that be necessary? Well, if we take a look at the code of our library, let's see, recent files. Here we go. See this? These are 1259 lines of code available to be used by you on your Arduino. Now, if you would want everything in here to function on your Arduino, let's say every light, beacon, flaps, you would need 1200. You need to write 1200 lines of code. That's not quite feasible, very prone to errors, and your code would get unreadable as insert swear words. So what we've done, we've included a library. It will include the entire file, and then we create an object. I'm going to say bits and droids flight connector. And we're going to give the object a name. And I always like to use the word connector because it's, why not? And we pass the variable false if you have an Omega or Nano, and true if you have a Pro Micro or a Leonardo. It's not really necessary if you use this as well. So I'm working on leaving this out in the future, but for now you still have to put in false or true, but most of the time it's going to be false. Now we have a connector, and the connector itself has these functions built in. So we have a connector that has this function. So how do we say connector, do this function or execute this function? Well, we go back to our sketch. We literally say, because it has a name, we're going to be calling it by its name. I'm going to say connector dot Control V, send flaps inc. And we could do exactly the same. Just let's just copy this entire thing, put it in here, send flaps decrease. Upload the code. Okay, so that is done. I'm gonna restart the connector for a second because there is a chance that because it re-uploaded code, it lost connection, etc. So just to be sure, I'm gonna restart it. Now I've got to wait till the game responds again. It usually doesn't like it when you reprogram something when it's still running. Very misty today. It's Amsterdam, not only Amsterdam, but the entire area. This morning I brought the missus to work and I think I had like 200 meters of vision in the car. So what did we say? We said something with the flaps, right? Let's see. do we have the serial monitor open? No, right? Or do we? Yes, we do. Okay, let's just restart it. Ah, yeah. You need to have the serial monitor closed when you use the connector, just as a heads up. But we can see that the buttons now correspond to the functions increase flaps and decrease flaps. Now, if you go to the article and copy this code, you'll notice that this part will probably be the only thing that's different. So we have send flaps inc and send flaps decrease. If you want to hot swap it, the only thing you need to do is go back to your list and yeah, autopilot master on. Here we go. Why not? Be careful, because I saw that. Here we go. See the double dot, and this one is still. And there's a space here, so get those out. Here we go. Send swap knife 2. I don't know why, but if you want it, you'll get it. Here we go. So now it will swap the nav2 and send the autopilot on. And that's all there is to it. So now just stop the connection. Hit start. Pull down on the throttle. And it should do something else. This one would autopilot, that one. Oh, here we go, this one. Swap nav2 and turn autopilot on or off. So everything is working. And that's all there is to a push button, actually. You can just add as many as you like. There are some ways to shorten your code if you have many, but we won't go into that much detail right now, because I first want you to understand how it works, and later on we can make a code more efficient with loops and etc. Right now, this will suffice. If it's low for internal pull-up, so input pull-up, don't forget to define it as an input pull-up. If you want to check if it's high, you need a pull-down resistor, and we need to declare it as an input. So if you encounter code on the internet that uses either of these two, now you actually know how to wire it, how it looks, and how the code behaves. And I hope this will give you a bit more insight on how you can easily implement this yourself. I think this is one of the easier components to hook up to. Now we could also illustrate the working, like how a button works. This is the left part, this is the right part, and we could just simulate a button press by connecting both with a wire when it's pressed and removing it when it isn't. So that will give you a clear view of how the button works internally. Wire 1, wire 2, the moment you press, they connect. The moment you release, they release. So that's all there is today, guys. It was a really deep dive into the buttons. This video will be helped made possible by Andre. He was my first Patreon out here. So you're gonna see his name in the screen at the end of the video every time. Thank you very much. If you want your name up here as well, go check out my page. And I hope to see you next time when we're gonna talk about rotary encoders. And tomorrow, the day after, I'm gonna have a video about some of the Airbus components that are coming up. One of them being these little boys. They are actually based on a toggle switch. There's a bit of glue here that I didn't clean up properly yet, but let's see. Can you hear it? It's such a satisfying clunk when you... And most designs have them sit on top of the toggle switches, but here it really, in this one, it really flicks them, so it doesn't, I don't know, I don't think it's going to be very stable when you put it directly on the switches. This one is stable as hell, and you can just mount these in any box you'd like. See, there's just a little edge here where you can just put it in and place it in your own projects as well. So that one is coming up. I want to thank you for watching, and I hope to see you next time.